Hey everyone, and welcome back for another deep dive with us.
Glad to be here.
Today, we're going to be tackling a topic that's been making waves all over the tech world.
Absolutely.
Large language models, or as you might hear them, called LLMs.
Yeah, you hear that a lot more these days.
Our deep dive is going to be based on excerpts from
Okay.
building large language models for production.
Oh, very good.
We're going to extract the key insights, and by the end, you'll have a pretty solid understanding of what LLMs are, how they work, and how they can be used, and what their potential impact might be.
Right.
So to kick things off, maybe you can give us a clear, jargon-free definition of what an LLM actually is.
Okay, so LLMs are basically AI systems that can understand and generate human-like text.
Okay, so it's like having a super-powered writing assistant that's read like every book imaginable.
Right, and it's trying to use all that information to communicate like we do.
Wow, that's pretty mind-blowing. But this whole idea of LLMs, it's not like they just appeared overnight, right?
Oh, no, not at all.
There must have been a whole evolutionary process leading up to this.
Yeah, so if we go back to the early days of natural language processing, or NLP as it's called.
Oh yeah, NLP, I've heard of that.
We were using much simpler methods.
Okay.
Like think about just counting how often each word appears in a text.
Oh, wow.
You know, that gives you some basic information about what's going on.
Yeah.
But it misses all the nuance and the complexity of language.
Right, so it's like judging a book by its cover.
Exactly.
You get the gist, but you miss the whole story.
Precisely.
Okay, so then what? What was the next big step?
Neural networks.
Okay.
This was a major leap forward.
Okay.
Because instead of just counting words, neural networks can actually grasp relationships between words, like how they're connected and the meaning in context.
Yeah, so it's like moving from a basic dictionary definition to actually understanding how words are used in different situations.
Exactly, and then came the real game changer.
What was that?
The transformer architecture.
Okay, I've heard of that.
This totally revolutionized how LLMs process information.
Interesting.
So instead of looking at each word one by one, transformers can analyze entire sentences or even paragraphs at once.
Oh, wow. That makes them so much more efficient then.
Yes, much faster and more efficient.
So is this where those big names like BERT and GPT and T5 come in?
You got it.
Yeah, those are like the rock stars of the LLM world.
They're based on this transformer architecture.
Okay.
And they've really pushed the boundaries of what's possible with language AI.
And they're showing up everywhere. Like I'm seeing them in search engines, chatbots, even in creative tools that I use.
Absolutely, they're everywhere.
Okay, so we've got a sense of what LLMs are and how they've evolved over time.
Right.
But what about actually building one? Like, is it as easy as just feeding a computer a bunch of text and letting it figure things out?
I wish it were that simple.
Okay.
Building an LLM, it's a complex process.
Okay.
It's like trying to brew the perfect cup of coffee.
I like that analogy.
You need the right ingredients, the right equipment, and the right technique.
Okay, so let's start with the ingredients then.
Okay.
The data.
Right.
What kind of data do we need, and just how much are we talking here?
Data is crucial. It really is the lifeblood of an LLM.
Okay.
And we need massive amounts of high-quality text data.
So like books, articles, websites, code?
Exactly.
Oh, wow.
And even social media posts.
Okay.
And the more diverse the data, the better.
Right, so it's like exposing a child to a rich linguistic environment.
Yeah, that's a good way to put it.
The more they hear and read, the better they'll understand and speak their language.
Exactly. And we're talking about huge amounts of data.
Like how huge?
Like terabytes, even petabytes of data.
Petabytes. That's like an unimaginable amount.
It is. It's a lot of data.
So I'm guessing that makes building an LLM pretty resource intensive.
It can be.
Okay.
But thankfully, we have access to vast public data sets.
No, it's good.
And cloud computing platforms can handle the processing power and storage.
Okay, so we've got the data, the ingredients, as you said.
Right.
But what about the brewing technique? How do we actually train an LLM to make sense of all this information?
Okay, so that's where the training process comes in.
Okay.
We use really sophisticated algorithms and optimization techniques to guide the LLM's learning.
So it's not just like throwing data at it and hoping for the best.
No. It's much more involved than that.
Okay.
Imagine you give the LLM a huge jigsaw puzzle, but you don't show it the picture on the box.
Yeah, so it has to figure out how all the pieces fit together based on their shapes and colors.
Exactly.
Wow.
We give it feedback along the way,
Okay.
helping it learn from its mistakes and gradually improve.
So it's like a constant back and forth between the LLM trying to figure things out and us giving it feedback and guidance.
Exactly. We give it a set of objectives like predicting the next word in a sentence or translating from one language to another.
And how do you measure how well it's doing with those objectives?
We use what's called a loss function.
A loss function.
It basically measures how far off the LLM is in its predictions or translations.
So the lower the loss, the better the LLM is doing.
You got it.
Okay.
And we use algorithms to tweak the model's internal settings to try to reduce that loss and improve performance.
So it's like fine-tuning a musical instrument.
Yeah.
To get the perfect pitch, you make tiny adjustments until it sounds just right.
Exactly. And just like a musician practices for hours and hours.
LLMs need tons of training.
They do.
Okay, so we've got the data, we've got the training process, and we've got a whole lot of fine-tuning.
Right.
But now what? What's the point of all this effort? Like, what are these LLMs actually used for in the real world?
That's where things get really exciting.
Okay, tell me more.
LLMs aren't just research projects stuck in labs anymore.
Okay.
They're being used in tons of real-world applications.
Okay, give me some examples.
Like enhancing customer service, powering creative tools, even accelerating scientific discoveries.
Wow.
They're really making a difference.
So let's dive into some of those real-world examples then. Like, how are LLMs being used to change the way businesses interact with their customers?
Okay, so imagine a company that's just drowning in customer inquiries.
Yeah.
Like emails, chats, social media messages.
I can see that happening.
Yeah, it's a common problem, and it leads to long wait times and frustrated customers.
Definitely.
Now imagine an LLM that's been trained on all the company's product information.
Yeah.
FAQs, past customer interactions.
So they're essentially building like a virtual customer service representative.
Exactly. They can handle all those basic inquiries.
That's pretty smart.
They can answer questions, track orders, even troubleshoot some technical issues.
Wow.
All without a human having to intervene.
So that frees up human agents to focus on the more complex or sensitive cases.
Right. It's all about finding that balance between automation and human interaction.
Okay, that's a great example of how LLMs can really streamline customer service. But what about more creative applications? How are LLMs being used to empower writers, artists, and marketers?
Okay, so picture a writer staring at a blank page.
Yeah.
Total writer's block.
It's the worst.
It is.
Oh, frustrating.
Now imagine an LLM trained on a huge amount of text that can generate different writing styles. From poems to scripts to marketing copy.
It becomes like a creative collaborator. It's almost like a brainstorming partner.
Yeah.
That can help writers overcome those mental blocks.
Right. You can suggest storylines.
Oh, wow.
Come up with catchy headlines. Or even draft entire paragraphs.
Really?
All based on a few keywords or prompts.
It's like having a digital muse.
Exactly.
Whispering creative possibilities in your ear.
It's a really powerful tool for anyone who works with words.
I can see that.
It can make them more efficient, more creative, and ultimately more productive.
This is incredible. We've got LLMs transforming customer service, igniting creative sparks. What other fields are being revolutionized by this technology?
Okay, let's step into the world of scientific research.
Okay.
Imagine a team of scientists sifting through mountains of research papers.
Yeah, trying to make sense of it all.
Exactly. Trying to connect the dots and uncover hidden patterns.
That must take forever.
It does. It's time-consuming and often pretty tedious.
Yeah.
Now, picture an LLM trained on a massive database of scientific literature that can analyze complex data, identify relationships between concepts, and even generate hypotheses.
Wow. So the LLM becomes like a research assistant.
Exactly.
Helping scientists speed up their discoveries and make breakthroughs that might have taken years to achieve manually.
Exactly.
That's mind-blowing. So these LLMs designed to understand language are now helping to unlock the secrets of the universe.
It's really quite remarkable how versatile they are.
Okay, so we've talked about these amazing applications, but let's get practical for a moment. What does it actually take to deploy these massive models in a real-world setting? I mean, you can't just run them on any old laptop.
No. LLMs, they need serious computational power.
Okay, so what are we talking about here?
We're talking high-performance GPUs.
Okay.
Even specialized hardware, like Google's TPUs.
Wow.
And then there's storage.
Yeah, because we've already established that LLMs need tons of data.
Exactly. We need systems that can handle those vast amounts of data.
So it's all about finding the right balance of hardware optimizing those data pipelines and just making sure everything runs smoothly.
It's a big job.
It sounds like a massive undertaking.
It can be.
Okay.
But luckily, cloud providers like AWS, Google Cloud, and Azure,
Okay, yeah, I've heard of those.
they offer solutions that are specifically designed for LLMs.
Oh, that's good.
They give you scalable infrastructure.
Okay.
So you can adjust your computing power as needed.
So it's like having a utility company for AI.
Exactly.
You only pay for what you use. Okay, that makes a lot of sense. Flexibility is key when you're dealing with such a dynamic technology.
Absolutely.
But I imagine security is also a major concern, right?
Absolutely.
Especially when you're dealing with potentially sensitive data.
Security is paramount.
Okay, so what are the key things to consider when it comes to securing LLM deployments?
We need multiple layers of protection.
Okay.
Things like encryption, access controls, and even techniques to detect and prevent adversarial attacks.
Adversarial attacks, what are those?
That's where someone tries to trick the LLM into behaving badly.
Oh, wow, that's scary.
We have to be very careful.
Okay, so it's like a digital arms race.
Yeah, in a way.
Constantly trying to stay one step ahead of the bad guys.
Exactly.
What about compliance? I imagine there are tons of regulations to consider.
There are.
Especially in fields like healthcare and finance.
Absolutely.
So how do we ensure that these LLM deployments are not just secure, but also legally and ethically sound?
Compliance is crucial. We have to make sure that LLMs are developed and used in a way that respects data privacy regulations.
Okay.
Like GDPR and HIPAA.
So it's not just about the technology itself.
Right.
It's about using it responsibly and ethically.
Exactly. Well said.
Okay, so we've explored some of the exciting possibilities of LLMs, but we've also touched on some of the challenges, like security compliance and the sheer scale of these deployments. Now let's dive even deeper into the world of data management for production-level LLMs.
Right.
This is where the rubber meets the road, right?
Absolutely.
Having all this amazing technology is great, but it's the data that makes these models tick.
Data is the fuel.
So let's break it down. What are the key stages in the data lifecycle for an LLM?
It all starts with data collection.
Okay.
And unlike initial training, where you might use vast public data sets, production-level models often use a blend of internal company data and external sources.
So it's about tailoring the data to the specific needs of the application.
Exactly. It's about making sure the LLM is trained on data that's relevant to the real world.
That makes a lot of sense. So what happens after we've gathered the data?
Then comes a crucial step of data cleansing and pre-processing.
Data cleansing. What is that?
It's all about cleaning up inconsistencies, correcting errors, and formatting the data in a way that the LLM can understand.
So it's like prepping the ingredients before you start cooking.
Exactly.
Chopping, measuring. You don't want to end up with a dish that's full of dirt or inconsistencies.
No, you don't. This step is often overlooked, but it's absolutely essential for ensuring data quality.
So what are some of the techniques involved in data cleansing?
Well, it could include deduplication, normalization, and even language-specific pre-processing like tokenization.
Tokenization, what's that?
That's where we break down text into smaller units that the model can process.
Oh, okay, so it's like breaking down a sentence into individual words or phrases.
Exactly.
Okay, so we've collected the data, we've prepped it.
Right.
What's next? Is it time to feed it to the LLM?
Not quite.
Okay.
For many applications, we need to label the data.
Data labeling. Okay, what is that?
That's where we add tags or annotations to the data to help the LLM understand the context and the relationships within the information.
So if we're training an LLM to identify different types of flowers in images, we would label each image with the correct flower name.
Precisely.
Got it.
Labeling can be done manually, which is very accurate, but it can be time-consuming.
Especially with these massive data sets.
Right. But thankfully, there are techniques like semi-supervised learning and weak supervision that can automate parts of the process.
So it's a mix of human expertise and AI assistance.
Exactly.
Okay, so the data is labeled. What happens next?
We need to think about storage.
Storage,
We need storage solutions that can handle the vast amounts of data that LLMs require.
So it's like building a massive library to house all this information.
It is.
But it's not just about storage capacity, right? We also need to be able to access that data quickly.
Exactly. Data retrieval speed is crucial, especially in real-time applications.
Because The LLM can't just sit there waiting for the information it needs.
No, it can't. We need low latency and high throughput.
So it's like having a well-organized library with a quick and efficient checkout system.
Precisely.
Okay, so we've collected the data, we've prepped it, we've labeled it, we've stored it.
Okay.
What about security and compliance? Those seem like pretty critical considerations.
They are. Absolutely.
Especially when you're dealing with sensitive information.
Security and compliance are paramount.
Okay.
Throughout this entire data lifecycle.
So what are some of the key security measures that need to be in place?
We need robust security measures to protect the data from unauthorized access, both at rest and in transit. Things like encryption, access controls, regular security audits.
So it's like building a digital fortress around the data with multiple layers of protection.
Multiple layers, yeah.
To keep it safe from prying eyes or malicious actors.
Precisely.
And then compliance. What are some of the regulations we need to be aware of?
We need to make sure our data management practices follow all the relevant data privacy regulations. Like GDPR, IPA, CCPA.
So it's about being a good citizen in the digital world.
Yes.
Respecting privacy and adhering to the rules.
Absolutely.
It sounds like a lot of responsibility rests on the shoulders of the teams building and deploying these systems.
It does.
But I can see how crucial it is to get data management right.
It's the foundation.
It's the foundation upon which the entire LLM system is built.
Exactly. Without efficient and ethical data management, even the most sophisticated LLM is going to struggle.
It's like trying to build a house on a shaky foundation.
Right.
It's not going to be stable or reliable. Okay, so now let's talk about keeping those LLMs in tip-top shape once they're deployed.
Right.
How do we make sure they continue to perform well and adapt to the ever-changing world of data?
Continuous monitoring and model improvement are essential.
Okay, so we can't just set them loose and hope for the best.
No.
It's an ongoing process.
It is.
Of observation, analysis, and adjustment.
Like tending a garden, you need to water it, fertilize it, prunes it regularly.
Okay, I like that analogy. So what specific metrics do we track to assess an LLM's performance in the wild?
We look at things like latency, error rates, throughput, and resource utilization.
Okay.
These metrics give us insights into how efficiently the LLM is operating.
Right, so it's about gathering data on the data, using metrics to understand how the LLM is performing in the real world.
Right.
What happens if we see problems like a drop in accuracy or an increase in errors?
It depends on how serious the issue is.
Okay.
And the potential impact on the application.
We might implement fallbacks.
Fallbacks, nice.
Okay, where the system gracefully handles those tricky queries by routing them to predefined responses. Or to secondary models.
Okay, so it's like having a safety net in place.
Right.
To catch any unexpected glitches.
Exactly.
And I'm guessing we also need a team of detectives. To investigate the root causes of those glitches.
Absolutely. We use error tracking tools to log issues so we can identify patterns.
And what about model drift? I've heard that term thrown around. What is that exactly?
The model drift is where the LLM's performance slowly degrades over time. As the data it's processing becomes different from the data it was trained on.
So it's like the LLM is getting rusty.
Yes.
Its knowledge is outdated.
Right.
As the world around it changes.
Exactly.
So how do we address that?
We can use statistical tests
to
compare the incoming data with the original training data. And if we see big differences, we can retrain the LLM with updated data.
So it's like giving the LLM a refresher course.
Updating its knowledge to align with the latest trends and patterns.
Precisely.
What other techniques are used to continuously improve LLM performance?
Active learning is a powerful one.
Active learning, okay.
It's where the LLM identifies cases where it's not sure about the output.
Oh, that's interesting.
And it flags those cases for human review.
So the LLM is asking for help.
Yeah, in a way.
It's identifying its own knowledge gaps and seeking guidance to improve.
Exactly. It's a collaborative learning process.
Between humans and AI.
Right.
That's fascinating. So maintaining an LLM in production, it's a dynamic process.
It is.
It requires technical expertise, data savvy, and a constant drive to learn and improve.
Well said.
Now let's talk about some advanced techniques for customizing and extending LLMs.
Right.
We've talked about how to train them, how to maintain them.
Right.
But how do we really unleash their full potential?
Okay, so one really exciting area is building custom LLM architectures.
Custom architectures. What does that mean?
It means going beyond using those pre-trained models.
Okay.
And actually designing and training LLMs from scratch.
From scratch.
Tailored to specific tasks or domains.
So it's like creating a bespoke suit.
Exactly.
Instead of buying one off the rack.
Right. It fits perfectly, and it performs exactly as you need it to.
Okay, that's a great analogy. So it's like building a custom-designed house instead of buying a prefabricated one.
Yeah, you have more control over the layout, the materials, the overall style.
And with LLMs, you have more control over the model's design?
Exactly. Things like the number of layers, the attention heads, the hidden dimensions.
So you're fine-tuning the model's architecture to get the best possible performance for a specific task.
Exactly.
It's like fine-tuning the engine of a race car.
Yes.
To get optimal performance for a specific track.
Right. You wouldn't use the same engine for a Formula One race and a NASCAR race.
Exactly. So different tasks require different model architectures.
They do.
Just like different races require different car designs?
Precisely.
Okay, so we can build these custom LLM architectures. What other techniques are used to extend the capabilities of LLMs?
We can integrate LLMs with other machine learning models.
Okay.
Creating hybrid systems that combine the strengths of different approaches.
So it's like assembling a team of specialists.
Exactly.
Each with their own unique skills to tackle a complex challenge.
Right.
You might have a data analyst, a statistician, a machine learning expert all working together to solve a problem that no single individual could handle alone.
Exactly.
And with LLMs, we can combine them with other models like convolutional neural networks or graph neural networks to process images or analyze structured data.
Exactly.
So we're creating systems that can understand information from multiple sources, not just text.
It's really expanding the possibilities.
Okay, so we can build these hybrid systems.
Right.
What other ways can we make LLMs even smarter?
We can enhance their contextual awareness.
Contextual awareness.
Okay, what does that mean?
So LLMs typically process text sequentially. But we can improve their ability to maintain context over longer conversations or documents by incorporating memory mechanisms and context retrieval techniques.
So it's like giving the LLM a better memory.
Exactly.
Allowing it to remember previous interactions
Right.
and use that information to provide more relevant responses.
It's like having a conversation with someone who actually listens and remembers what you said.
Instead of just responding to each sentence in isolation.
Precisely.
What other ways can we enhance their capabilities?
We can improve their knowledge integration.
Knowledge integration.
We can connect LLMs to external knowledge sources, like knowledge graphs or databases.
It's like giving the LLM access to a massive online encyclopedia.
Exactly.
I can instantly pull in facts and figures.
It can.
And incorporate them into its responses.
It's like having a super-powered research assistant. Okay, that's amazing. And what about multimodal capabilities? I've heard that's a big area of research.
It is.
What does that mean?
So instead of just processing text, we can train LLMs to process images, videos, and audio.
So it's like giving the LLM senses.
Exactly.
It can experience the world in a much richer way.
It can analyze information from multiple sources.
Okay, so we've got custom architectures, hybrid systems, contextual awareness, knowledge integration, and multimodal capabilities.
It's really quite amazing.
It sounds like the possibilities for extending LLMs are practically limitless.
They really are. And as the field continues to evolve, we can expect even more creative and innovative ways to enhance these tools.
Okay, so we've explored the technical side, but let's talk about the practical side.
Okay.
How do we integrate these advanced LLMs into real-world systems and applications?
Integration is key.
Okay.
We need to make it easy for LLMs to communicate and interact with other software systems.
So how do we do that?
One common approach is to develop APIs. Application programming interfaces.
Right.
They expose the LLM's functionalities, allowing other programs to access and use its capabilities.
So it's like creating a universal translator that allows different software systems to speak the same language and exchange information seamlessly.
It's all about breaking down barriers
between different technological ecosystems, allowing them to work together harmoniously.
Precisely.
Okay, so APIs are one way to integrate LLMs. What are some other integration strategies?
We can deploy LLMs as microservices.
Microservices.
Okay, what are those?
It's a software architecture style.
Okay.
Where we break down large, complex applications into smaller, independent services that communicate with each other. LLMs can be packaged as microservices, which makes them really easy to integrate into different systems.
So it's like building a modular system?
Yeah.
Where each component has a specific function?
And you can assemble those components in different ways to create all sorts of applications.
Exactly. It's like having a set of Lego blocks
I like that.
that you can use to build anything you can imagine.
Okay, so microservices provide that flexibility and scalability that we need when working with LLMs.
Absolutely.
Okay, so we've got APIs, microservices.
Okay.
What other techniques are used to integrate LLMs into the real world?
Data pipelines are essential.
Data pipelines.
We need to make sure that the data flowing into and out of the LLM is properly formatted, cleansed, and validated.
So it's like building a network of pipes and filters to make sure the data is processed and delivered to the LLM correctly.
Exactly.
You don't want to clog the system with dirty or inconsistent data.
No, you don't.
And what about automating some of these processes?
Workflow automation is key. We can use tools like robotic process automation or RPA or workflow management systems to automate those tasks that involve LLMs.
So this frees up human workers to focus on more strategic activities.
Exactly.
Okay, so we've got a whole toolbox of techniques for integrating LLMs.
We do.
Including APIs, microservices, data pipelines, and workflow automation.
It's all about making those LLMs work seamlessly in the real world.
It sounds like the possibilities for using these powerful tools are endless.
They really are, and I think we're only just beginning to scratch the surface.
Now let's shift gears and talk about LLM security and compliance.
Okay.
These are essential considerations.
They are.
Especially as these models handle increasingly sensitive information.
Absolutely.
We've talked about the potential for misuse.
Right.
But what concrete steps can we take to protect these models and the data they process?
Security and compliance are absolutely critical when we deploy LLMs in real-world settings.
So let's break down this security fortress. What are the essential layers of protection?
First, we need to secure the data itself. That means encryption, both when the data is stored and when it's being transmitted, to protect it from unauthorized access. Access controls are also crucial, making sure only the right people can see or change the data.
So it's like building a vault around the data with multiple locks and security checks.
Multiple layers of protection, yes.
And then what about the LLM itself? How do we protect that from unauthorized access or tampering?
We need to secure the model's code, its configuration files, and any other sensitive components.
So we're not just protecting the data.
Right.
We're protecting the brains of the operation.
Exactly.
The LLM itself.
Precisely.
What other security threats do we need to be aware of?
Adversarial attacks.
Right. We talked about those earlier.
We need to implement robust training techniques and monitoring systems to detect any unusual activity.
So it's like having a security team that's always on high alert?
Yes, always watching for any signs of trouble.
Okay, and then there are the privacy implications of LLMs.
Right.
These models can sometimes memorize information from the data they're trained on.
They can.
Which could potentially lead to privacy breaches.
It's a valid concern.
So even if we anonymize the data, there's still a risk that the LLM could remember some sensitive details. How do we address that?
That's where techniques like differential privacy come in.
Differential privacy? What is that?
It involves adding noise to the data in a very controlled way, making it much harder to extract individual data points.
So it's like blurring out faces in a photo.
Yeah, that's a good analogy.
To protect people's identities while still showing the overall scene.
Exactly.
Okay, so we've got encryption, access controls, protection against adversarial attacks, and differential privacy.
It's all about creating a layered defense system.
Okay, it sounds like a pretty comprehensive security strategy.
It is.
But what about compliance? There are so many regulations to consider.
There are.
Especially in fields like healthcare and finance.
Compliance is crucial.
Okay.
We have to make absolutely sure that our LLM systems follow all the data privacy regulations.
Like GDPR, EPA, CCPA?
All of them.
Yes. So it's about using these powerful technologies responsibly and ethically.
Well said.
And it's an ongoing process, right?
It is.
As regulations change and new challenges arise, we need to adapt our security and compliance measures.
We always have to be evolving.
Okay. We've covered a lot of ground today.
We have.
From the basics of LLMs to the complexities of data management, security, and compliance.
It's a lot to take in.
It is. It's clear that this is a complex and rapidly evolving field.
It really is, but it's also incredibly exciting.
It is exciting. LLMs are transforming so many industries.
They are.
And impacting so many aspects of our lives.
It's amazing to see the progress that's being made.
It really is. And as the technology continues to advance, we can expect even more groundbreaking applications.
I have no doubt about that.
It really is amazing to think about how far LLMs have come in such a short time.
It is. It feels like every day there's something new and incredible happening.
From those early chatbots that were kind of clunky.
Oh, yeah, I remember those.
To now, where they're being used as research assistants, creative collaborators.
It's mind-blowing.
It really is.
Yeah.
They're already having such a big impact on our lives.
They are, and we're just getting started.
Exactly. So what's next? Where is this whole LLM revolution heading?
Oh, the future of LLMs is just brimming with possibilities.
Okay, give me a sneak peek.
Researchers are pushing the boundaries all the time, exploring new architectures, new training techniques, expanding their capabilities in ways we haven't even thought of yet.
So what are some of the things that you're most excited about?
As an expert in this field, one area that I think has huge potential is developing more efficient models.
Efficient models? What do you mean by that?
So as LLMs get more complex and they need more and more data,
You're right.
It takes a lot of computing power to run them.
Yeah, that makes sense.
So researchers are looking for ways to reduce those computational demands without sacrificing performance.
So it's like making them leaner and meaner.
Exactly.
Yeah.
And this could lead to LLMs that can run on much smaller devices.
Oh, wow. So instead of needing a huge data center, we
yeah.
could run LLMs on our smartphones.
Maybe even on tiny sensors.
Wow.
Embedded in everyday objects.
Okay, so that opens up a whole new world of possibilities.
It does for mobile computing, for edge computing.
What other advancements are on the horizon?
Another really exciting area is multimodal LLMs.
Multimodal LLM. Okay, I think we touched on this earlier.
He did.
But remind me what that means again.
So these are LLMs that can process more than just text.
Okay.
They can understand images, videos, audio.
So it's like giving the LLM senses, allowing it to experience the world in a much richer and more complete way.
Precisely. Imagine an LLM that can analyze a busy city street. It could understand the visual information like the cars and buildings, but also the sounds like the traffic and the conversations.
It's like giving the LLM a whole new level of understanding.
It is. It's really incredible.
So what are some of the potential applications of these multimodal LLMs?
Oh, the possibilities are vast.
Okay, give me some examples.
In healthcare, they could analyze medical images, patient records, even conversations with doctors.
To provide more accurate diagnoses.
Exactly. They could create personalized treatment plans.
Wow, that's amazing.
They could revolutionize education, too.
How so?
By creating immersive learning experiences that engage all the senses.
I like that.
And, of course, they could enhance our creative endeavors, allowing us to collaborate with AI systems that can create art music, even entire virtual worlds.
Wow, it sounds like we're on the verge of a whole new era of human-computer interaction.
I think we are.
Where AI systems aren't just tools anymore, but partners.
Partners in our exploration and understanding of the world.
Exactly. So as we wrap up our deep dive today, I want to leave our listeners with a question to think about.
All right.
We've talked about the technical marvels of LLMs, their potential benefits, and the importance of responsible development.
Absolutely.
But ultimately, the impact of these technologies depends on the choices we make.
That's true.
So how do you envision LLMs shaping the future?
It's a big question.
It is.
And it's one that we all need to consider.
What role do you want LLMs to play in your life, your work, your community?
It's up to us to decide how we want to use these powerful tools.
Exactly. Well, thank you so much for joining us today.
It's been a pleasure.
For this deep dive into the fascinating world of large language models.
I've really enjoyed our conversation.
Me too. We hope you've learned something new and that you're as excited about the future of LLMs as we are.
The possibilities are truly endless.
They are. Until next time, keep exploring, keep learning, and keep imagining